Now, if you look on page 527, number 11, this is actually a pretty simple problem. You've got two matrices that equal each other on the left and on the right. And then you have an algebraic expression. Here, let me show you that. Here, let me pause this for a second. I want to point to the book. Okay, so anyway, so here's 11. And so you've got these two matrices with all these elements the same, 16, 16, 4 and 4, etc. And then you have 5 on the left side, third element in the first row. But on the right side, you got 2x plus 7. Now, all you're going to do is you're going to make an equation, 2x plus 7 equals 5, and solve it. Go down to the next row, you get out, and you have 3y equals 12. Make an equation out of that and solve for y. And then in the third row, you've got 3z minus 14 equals 4. You use that to find z. And you can see that the math for this is trivial, and you can easily find x, y, and z with these three single variable equations. 2x plus 7 equals 5, 3y equals 12, 3z minus 14 equals 4. Okay, 13, let's look at that. And all we're doing, we've got a bunch of operations here. Adding matrix A to matrix B, subtracting B from A, and then 3 times A, and then 3A minus 2B. Now this is, again, it's really simple. Now you can only add and subtract two matrices if they have the same dimensions. This is a 2 by 2 and this is a 2 by 2, so they can be added together. You've got to have, each matrix has to have an element corresponding to all the elements in the other matrix in order for you to do addition or subtraction operations. So let's go back to the journal. So here's A plus B. Just take the corresponding elements and add them together. 5 plus 3, negative 2 plus 1, 3 minus 2, 6 plus 1. A minus B, it's the same thing. 3A, multiply every element by 3. 3A minus 2B, every element times 3 in A, minus twice every element in B. It's very, very straightforward. All right, 29. That's the next page. Let's take a look at 29. All right. Now, x equals 3a minus 2b. So that's about all we're going to do there. And let's look at the journal. And that's 3a minus 2b, and that's about all there is. Okay? 33. Matrix multiplication. Can matrix A be multiplied by matrix B? Now, in order to do matrix multiplication, the number of columns in the matrix on the left must equal the number of rows in the matrix on the right. They are not equal, so matrix multiplication cannot be performed. Why? Because matrix multiplication is performed in which the corresponding elements in a row on the left multiply corresponding elements in the column on the right. Okay, well, this row on the left has 2 elements, the column on the right has 3. So there's not a one-to-one correspondence between elements in the row on the left and the column on the right. Multiplication is not possible. Now, if you label the matrices, this matrix on the left, A is 3 by 2 and B is 3 by 3. You can see the inside numbers should be equal if you can do multiplication. If you can do multiplication, the dimensions of the product are the numbers on the right, rows, columns. Okay, 35. We got a 3 by 2 and a 2 by 2. Okay. The columns on the left match the rows on the right. Therefore, multiplication is possible. And you can see the inside numbers 2 and 2 match, and the dimensions of the product matrix is going to be 3 rows by 2 columns, 3 by 2, the outside numbers. Okay, and then down here I detail all the mathematical operations. -1 times 2 plus 6 times 0 is the first element in the first row. -1 times 3 plus 6 times 9 is the second element in the first row. That takes care of the first column. The first column, the first row on the left is what makes the first row in the product matrix. First row on the left and the first column on the right. Actually, both columns. Okay, second row on the left. -4 times 2 plus 5 times 0 is the first element on the left, and then -4 times 3 plus 5 times 9, and that makes the sum of these two products makes the second element in the second row. Finally, 0 times 2 plus 3 times 0 is 0. And then 0 times 3 plus 3 times 9 is 27. And so this is the product matrix is -2, 51, -8, 33, 0, 27. Now, 39. Is multiplication possible? Well, we have a 2 by 1. We have 1 column on the left, 1 row on the right. Therefore, matrix multiplication is possible. It's a 2 by 1 on the left and a 1 by 4 on the right. Therefore, the product matrix is going to be 2 by 4. Now let's start multiplying. This row times this column, 5 times -3, and that's all there is to the first element in the first row. This row times this column, 5 times -1, -5, that's just one product makes the second element, and so on. 5 times -5, -25, third element, first row. 5 times -9, -45, fourth element in the first row. Now we go to the second row, and we're going to multiply the second row times the elements in every column. So there's one element in the row in the second row on the left, and there's one element in the columns on the right. So there will only be one product in each element in the product matrix. 6 times -3, -18. 6 times -1, -6. 6 times -5, -30. 6 times -9, -54. 41. Okay. Now, this is a 2 by 2. This is a 2 by 2. So there's 2 columns on the left, 2 rows on the right, so it's going to be okay. And dimensions will be 2 by 2. So A times B, 0 times 2 plus 2 times -1 is 0. 1 times -1 plus 2 times 8 is 15. And now we are going to go to the second row. 4 times 2 is 8, minus 2 is 6, 4 times -4. 4 times -1 is -4, 2 times 8 is 16, and that's 12. And that's the product matrix, A times B. And now we do B times A. Well, that A times B does not equal B times A. Matrix multiplication is not commutative. And finally, A squared. You can work through that for yourself. Okay, now 59. Let's see what 59 is all about. I think it's on the next page. No, it was on the previous page. So. Okay. So we're going to solve this using the augmented matrix method. So here's the system of two equations. Negative x1 plus x2 equals 4. Negative 2x sub 1 plus x sub 2. Doesn't matter. These are two different variables. They could be x and y, a and b, or whatever. Don't get thrown by the fact that it's x sub 1 and x sub 2. Okay, so let's go to the journal. So I write out an augmented matrix with the coefficients, negative 1, 1, 4, negative 2, 1, 0. And I start doing the row manipulations. So the first row will be negative 2 times R1 minus R2, 2 times R1 minus R2. Okay, so that'll be negative 2 plus 2, that's 0. And so then I get 0, 1, and 8 in the first row. 2 times R1 minus R2, that's 2 minus 1 is 1. 2 times R1 minus R2, okay, that's going to be 8. Okay, so I get 0, 1, and 8 in the first row. Then I take negative R2 plus R1. Negative R2 plus R1, okay. And that's going to give me 1. And then this will give me a 0 and a 4. So x sub 1 equals 4 and x sub 2 equals 8, because the way this is set up, this column here is for x sub 1, this column is x sub 2, and then these are the solutions on the right. So I got 1x sub 2 equals 8, and 1x sub 1 equals 4. 63, which I believe is the last problem. Let's see what 63 is all about. Same thing, only now we've got 3 variables, x sub 1, x sub 2, and x sub 3. So let's go back to the journal. Here is the augmented matrix, and now I start my row operations. Now, here is my goal. I want to end up looking like this, 1, 0, 0, 1. In other words, 1x sub 1 equals 1. 1x sub 2 with nothing else equals negative 1. I'm showing you the answers or whatever. And then 0, 0, 1x sub 3 equals a number on the right. Okay, so let's go up. How do we get there? So my first goal is simply to get 1, 0, 0 in this left-hand column. So I just bring down your row 1, because it's already there. 1, negative 2, 3, 9. I'll worry about the rest of the numbers later. I take R1 plus R2. That's pretty obvious. That's going to give me 0, 1, 2, 3 in the second row. And finally, to get a 0 in the first element in the third row, I'll take R3 plus 2R2. And that'll give me 0, 1, 3, 5 in this row. Okay? Now my next goal is to eliminate this 1. And that will give me the solution for x sub 3. Plus it'll give me a row in which I got 2 zeros in the first 2 elements, which I can then use to fix these other 2 rows and get zeros in all the other positions when I want them. Namely, I want a 0 here and I want a 0 here. But first I want to get a 0 here. So, but along the way I can do myself a little bit of good. So I'm going to take R1 plus 2R2. That's pretty obvious, and that'll give me a 0 here. I just bring down R2 as it is. There's nothing I can do with it right now. I can't combine it with R1, because that'll put a 1 here, so that's no good for me. So R2, but R2's okay. So now things looking better. I got a 1, 0, 0, 1. So, and then finally, I'll take R3 minus R2, and that'll give me a 0 here. And it happens to give me a 1 here. So I know that 1, 1, x sub 3 equals 2. So Now I've got a handy tool for fixing the rest of the matrix, okay? So now I'm going to take R sub 1 minus 7R sub 3. And that'll give me a 0 here. R sub 1 minus 7R sub 3, and it gives me 1, 0, 0, 1. So I now know that x sub 1 equals, I now know that x sub 1 equals 1. And then I take R sub 1 minus 2 R sub 3, R sub 1 minus 2R sub 3. That's not right. R sub 1, I'm doing R sub 1 minus 7. Oh, no, that's right. I'm sorry. R sub 1, this is R sub 2. This is a typo. R sub 2 minus 2R sub 3. Sorry about that. R sub 2 minus 2R sub 3, and that'll give me a 0 here. Okay, in the third row, this is simply R3. That's right here. Okay, anyway. So 1, 0, 0, 1, 0, 1, 0, negative 1, 0, 0, 1, 2. Okay, I now know that x sub 1 is 1, x sub 2 is negative 1, and x sub 3 is 2. That's it for the homework for 7.5.